All right. Thanks everyone for your patience. I hope you won't have this issue again. So today I first want to go through the survey results that you guys actually filled out last week, which I found interesting. So can everybody see all this? Yeah. Okay. So why do you want to learn Python? So C is I want to apply for tech jobs. So which is nice that you guys are interested in getting jobs in tech industry. And the second one was I want to use it to start my own company or do my own research, which is interesting. There is one person who actually selected this course because he or she didn't have any other option, which is interesting. And so what is your experience with Python? Looks like most of you guys have a little bit of experience, which is nice. And there is one pro in the class. I would love to talk to him or her, and looking for help from this person. Thank you so much. Okay, and for the operating system you use, yes, most of you use Microsoft. I was actually happy to see that there are about 10 people who use Linux. I hope it will increase at the end of this course. I hope I can encourage you more to use Linux. Okay, so are you familiar with terminal, console, or shell? And most of you guys said briefly. And yeah, and there are also like lots of people who don't have any idea. So I hope you guys start feeling a little bit better with that. And for Git and GitHub, it's very similar to the Python knowledge you guys have. So briefly, most of you said. And yeah, there are actually people who use it, who are very comfortable with that, which is nice to see. Okay, so algorithms and data structures, which I think is really important, especially if you want to interview for jobs as a software engineer or maybe data scientist. So for that, yeah, most of you said briefly, but again, this is not a course to learn these things, but still, I will do my best to remind you those concepts or review them when you are applying Python concepts. So do you want to be well prepared for software engineering interviews at big companies? 41 of you, I mean, I think this is almost like 95% said actually absolutely, which is nice. So there is one person who said, I don't care, which is interesting. Thanks for honesty. Okay, so that's it. So for the GitHub account, does everybody have their GitHub accounts and put it to the Google document that I shared? Nobody had an issue, right? Okay. All right, and so let's go to PyCharm. Let's see. So last week we were left out with the PyCharm stuff. So everybody installed PyCharm, right? Yeah. You guys? Okay, perfect. So yours might look a little bit different than mine, but don't worry about it. So let's create a new project, okay? I mean, you can actually give any name to this. So I mean, you can also select a location or path in your machine. So I'll call it Lecture2, okay? And okay, so for Python interpreter here, so choose an existing interpreter, okay? Because last week you guys spent so much time on setting up your virtual environment and all that. So make sure that you actually have the one that you set up. So in my case, it's going to be EE551. So I'll select that one. And then I just say create. Okay. So is everybody clear with the virtual environment, the importance of virtual environments? I have a sense that you guys are a little bit confused about it. So you don't want to mess up with Python's, your system's original Python. So you usually want to separate your Python environment that you are working on, which might be different from project to project or from system's default Python. So you might need to install version 2 of one package for one project and version 3 of the same package for another project. And if you try to install both of them in the same environment, then you'll start getting conflicts with these dependencies. So that's why we are actually separating all these environments. So we have a virtual environment either for each project, or maybe for this class you should be okay with having only one virtual environment, I think. All right, so when you start the PyCharm, it actually gives you all these tips. So you can either look at those. I'm going to say close. Okay. So here I'm at lecture 2, right? So let's create a file here. I'll say new. So you can either say file, but then you shouldn't forget to add .py at the end of the file's name. Or you can just say Python file. Okay? So let's do Python file. And let's say hello. Yes, how did you know it?
Every language is first
Right, yes. So we have to do it too. All right, so I did that. So now I can see my hello world. By the way, is the font too small? Should I increase it? Okay, yeah. Yeah, do it. All right. Appearance. Okay. Let's do 16. Okay, I think it only changes here. It doesn't change how you see it here. Anyway, so you had this lecture 2, and there is only one file in that directory. So here I'm going to say print. Okay. Hello world. Okay, and now you save it. All right, and here you can actually right click and say run hello world. Here you see that the process finished with exit code 0, which means your program actually succeeded. There is no errors or no issues. And you can actually see the output of your program here that says hello world, right? Okay, so this is one thing I want to show you. And also there is a debugger in PyCharm, which is really nice. It can be really, really convenient to use, especially if you have a really complex program and you keep getting an error and you don't know how to solve it. And of course, one way to debug your program is putting prints everywhere, right? So you can print almost everything and then try to figure out what's going on, what's going wrong. But I assume none of you really prefer it. And one thing nice about being an engineer is it's based on laziness. You know, we are actually lazy. That's why we keep inventing and finding new ways of doing things, because we don't want to do lots of work. We want the machines to do the work for us. So for that, let's look at the debugger. Let's say let's declare a variable, let's say x equals 6, y equals 7, okay? And let's say, let's do something really stupid here, so we get a error, okay? So let's say x plus hello world. You know, I'm just learning Python, so I don't know, you know, I can try anything I want, nothing to break. And then I say, run again. Oops, I got an error. And since I'm new to Python, I don't really know what's going on here, right? So is everybody fine until here? Are you guys following well? Okay. All right, so here I say, okay, so there seems to be something here. So let's put a this little dot here that actually that tells PyCharm to stop over there. So if things run fine until that point, that means we are actually fine up to here, okay? And now you go to Hello World again and right click and say debug Hello World, okay? Oh, nice, it actually gave me this nice environment, right? I can actually see the variables that I assign, which is x equals 6, y equals 7, and which is what I really like is, so you can actually, no, sorry, not debugger. Okay. No, this is not what I want. It looks a little different in Mac. Maybe here. Oh, okay. No, not here. Sorry, I think I just closed my debugger. No, it's here. Oh, okay, sorry, it's here. Okay, so here I go. Okay, so the error was about some types. So I was having some issue with types. And here it actually remembers what I have until this point. So I can just look for type for x, for example. It actually gives me, it says it's an int. The result is integer. Oh, okay. Maybe I'm doing something really stupid here. So x is an integer. I'm trying to add an integer with, what is this hello world? String. So it doesn't make any sense. And of course, it's complaining. I say, okay, I got it. And then you close it. So you clean your breaking points. And then you say, okay, so maybe if I change this to string, maybe it will work, because now everything is the same. And then I say run. Oh, okay, now it's run. So I don't need to do debugging unless I have some suspicious results. Okay, so is everybody fine with this PyCharm and all that environment? Okay, you have a question? Yes, so you just put a breaking point wherever you want. Okay? And then you click on write on the file, and then you say debug hello world. And then it creates these nice windows down here for you. Okay? So this is nice. All right, so before we switch to something fun, more about really main concepts about Python, actually I prepared a quiz for you to make sure you guys read the assignments I gave to you. So I'm gonna distribute this, but please don't turn it over, okay? So when I tell you start, then you can start. So nobody really looks on the front page. And yeah, so prepare your pen, please. So everybody return it, right? So how was it? Easy, right? Not easy? Okay, so do you want me to go through it? Yes. Okay. All right. Okay, so what's the Linux command to delete all the PYC files in the current directory? C. Good. What is the Linux command to print the current directory? Right. What is the Linux command to list the contents of the current directory? Who said C? Okay, D, right? Good. What is the Linux command to move script1.py to subdirectory animal? D, right? Good. What is the git command that initializes, sorry for the typo, a new git directory? C, right? Okay. How do you stage file.py for commit? C, right? Right. How do you save the current state of your code into git version control with message first commit? B, right? Nice. How do you check the state of your local git repository since your last commit? B. Nice. What is the git command that downloads your repository from GitHub to your computer? A, right? Okay, nice. So what is the git command that uploads your changes and code back to GitHub? Git push. Okay, you guys did great. Okay, perfect. If you had trouble with this, I encourage you to read more about it, learn more about it, because we'll be using GitHub all the time. Okay. All right. Okay, now we can finally start something more fun, in my opinion. Okay. So let's go to the terminal, everybody. And so if your environment, virtual environment, was set up properly, you should be able to write work on and whatever environment name you have. So in my case, it was EE551. So for you, it might be different. Right? So can everybody do that? Okay, so here, since I installed IPython and IPython notebook, I can actually just write a Jupyter notebook, and then that actually starts me this browser. So can everybody run that? It might be IPython notebook for some of you. Okay. Is everybody fine with this? So can you guys all start it? No? So who has IPython notebook now running in their machine? Okay, only 4 of you. So what are the issues with the rest? Okay, so maybe you may need to type pip install Jupyter notebook in your environment. Or sorry, just Jupyter. So you can run this. It might work after this, because for some of you, when you installed IPython, it should have installed notebook as well, but sometimes you need to install it separately. It's not a big deal, don't worry. Okay, so in your case, if you succeeded to actually run this IPython notebook, you can actually say new and then click Python 3 here. It will actually create a new notebook for you. But in my case, since I already prepared a notebook for you guys, so I'll just click on the notebook that I saved before, and then I can start running things here. Okay. But I want to say something about this IPython notebook. So I don't know if I mentioned before, I'm really not a big fan of this, and I don't recommend it for like doing your assignments or doing some, I don't know, maybe development when you start a job in a tech company. So it's really it has some issues that I'll demonstrate. But I will be using it only for only during the lectures. Okay. So your assignments for your assignments you should be using PyCharm. All right. Okay. But before that, I need to connect this. Okay, so today we are going to go through the Python object types or data structures. So you can think a Python program as a composition of modules, statements, expressions, and objects. So what do I mean? So first, for a given program, you will have multiple modules. So each program can actually have its own modules. And for each module, you can have different statements. And inside each statement, you can have expressions. And finally, for each expression, you can actually create and process objects. So you can think module as .py files, every .py file you have. And statements is more like, let's say, function at each module. And within a function, whatever things you do, so they are the expressions. Okay? All right. So start with the easiest thing. So you can, as you can guess, you can do simple integer addition like this. So for example, here, if I run this cell, you know, it's just like standard program. By the way, the shortcut for running the cell is Shift-Enter if you don't want to hit this run every time. Okay. Here, so I talked about types a little bit. So here I'm actually multiplying an integer with a float number. So what do you think the output should be, the result should be? Should that be an integer or float, right? Because you go to the more complex type. All right, so 6.0 is a float, right? So let's say you want to take the power of 2. Let's say you want to do 2 to the power 100. So power operation in Python is really just double star. Okay. By the way, can everybody see this? Should I increase it even more? Should I zoom in more? No, right? Okay. All right. So so what is the result of this? Oh, you can't do the math in your head? All right. Yeah, it's a big number. Pretty big number. Okay. So besides expressions, there are also some numeric modules that you can use with Python. So those are actually the additional tools that we can just import. So for example, there is this module called math. Basically, all you need to do to use these math operations is just by saying import math. And then when you say math.py, what do you expect? Right, so you expect it to return you the pi value, which is already in this module. So all you need to do is import it. All right, and also let's say you want to take some like square root of some numbers. Again, you can use this math module, and all you need to say is math.square root of 81 in this case. Okay. So here, so math is the module. Dot square root is the method. So I'm calling a method that belongs to that module, and that method is square root. Okay? All right, so strings. So you can actually create a string like this, but when you create a string, you need to make sure it's in quotations. You can either use one quotation, or you can actually do, so these are both the same for Python. You can either do this or just do this. But you have to be consistent. You cannot do like both of those, okay? So let's do this. And then, so it creates a variable that is called s, and its value is span. Okay. And then I can find the length of this string, which should be what? Length of span is what? 4, right? So if you want to do that, all you need to do is say lens. So it is 4. Okay, so let's say I want to access items in this string s. Let's say I want to find the first item. So what is the first item of s? Again s, right? Okay, so for that, all you need to do is to say s in a bracket 0. So it gives me the item which is at index 0. Okay? And let's say you want the second item from the left. In that case, all you need to say is s1, which is p. And you can actually use this -1 to get the last item in your object or string. But does it have to be -1? Can you say something else here? 4 or 3? 3, right? Because in Python, indexing starts with 0. So the fourth element will have an index of 3. So in this case, but we can say -1 safely in this case, because it will always return the last value, s-1. Yes. Okay, so what do you think s-2 is? A, right? So it is the second from the last. In that case, right. Okay, so you can also slice from this string. Let's say I want to slice from the, is this the first item or the second item? Does it get second, right? So it's sliced from the second item through the last item, but is last item included? No. So when you do slicing, it gets the item with index 1, item with index 2, but it stops at index 3. So this is all you get, PA. Okay? Okay, so what about everything past the first? So I want to start from the second item and go all the way till the end. So in this case, you can say S1, and this you can just do column operator here. So it gives you, what is the output of this, you think? PAM, right? So it skips the first item. So you can do the same thing for the last. So you can put this column in front. So it starts from the first item and it goes all the way to the end, but it doesn't include the end, the final one. So in this case, this SPA. Nice, right? I like this slicing more. Okay, so what if we want all of those? We want to copy this. So you just put this, and then it will give you all the values, all the items. But here, this actually copies. So this is called a top-level copy. So it's kind of a shallow copy. I'll talk about it a little bit later. But just keep in mind that when you create a copy like this, whatever new variable you are assigning, it will actually point to the same location in your memory. So when you make a change in one of the variables, it will change the other variable too. So you need to be careful when you copy things. Are you doing a shallow copy, which means they share the same memory, or are you doing a deep copy, which creates entirely a new object and will be an independent object? Okay, so keep that in mind every time when you program in Python. Okay, so concatenation. So in this case, I say S plus XYZ. This is something similar what I try to show with Python, like adding two strings, right? So what does adding two strings mean? What can that mean? It's just concatenation, right? So this should, what do you expect as an output of this? Exactly, spam XYZ. So here you go. But isn't that interesting that plus operator works for strings too, right? It's not, these are not integers, these are not numbers, but still the works, which is something nice about Python. So it actually interprets that you are working with strings, and then instead of doing the real summation for numbers, it actually does the concatenation for strings. All right, what if you want to repeat this S 8 times? And again, we are lazy, we are engineers, we don't want to type it 8 times. So all you say is S times 8. So it will just generate this spam, like repeated 8 times. Okay? All right, so here I actually try to prepare you to talk a little bit about this polymorphism, which is a concept you guys should know what that means. So this is again. So notice that the plus sign means different things for different objects. So addition for numbers, concatenation for strings. So this is a general property of Python that we will call polymorphism. So the meaning of an operation depends on the objects being operated on. So plus can mean different things for different objects that you are using. Okay, so is everybody clear with polymorphism? Now. No? Yes? So if I do a quiz next week, can you guys answer this? Can, right? Okay, so other important thing about Python or Python objects is the immutability. So basically, strings are immutable in Python. So, which means they cannot be changed in place after they are created. Okay, this is important. For example, you can change a string by assigning to one of its position, but you can always build a new one and assign it to the same name. So this actually immutability can be used to guarantee that an object remains constant through your program. Let's say you work in a really big tech company, and there are some variables that you never want them to change. So you don't want any other developer come and edit the variables. So you want them to be immutable. That's where we use immutable objects. So strings are immutable. So let me demonstrate what that really means. So S was span, right? S-P-A-N. We just defined all the way up here, right? So it was span. So let's try to assign Z as the first item. So let's try to replace S with Z. Do you think it's gonna work? No, right? Who says yes, it should work? Okay. Yes, I got an error. Because the string object does not support item assignment because it's immutable. Okay? But what if I create another S variable and then say Z plus all the items but the first one in S? Do you think it works? It should work, right? So now we are reassigning the variable S to something else. So we are telling the interpreter, Python interpreter, okay, forget about spam. Now let's remember spam, right? Okay, so if I run this, okay, good, it worked. But what happened to the old one? So we'll talk about it. So here, every object in Python is again classified either immutable or not. So in terms of the core types, numbers, so numbers, strings, and tuples are immutable. So you should know this. When you program in Python, the strings, numbers, tuples, these are immutable. But lists, dictionaries, and sets are not. So they are actually they can be changed in place freely without reassigning a new variable. And so these are actually the most of the objects that you will code anyway. Okay, so in addition to the generic sequence operations, strings also have their own available methods because strings are special objects that you might want to do specific things with only strings, which you may not really need with other object types. So methods are actually the functions that are attached to and act upon a specific object. So you can think that methods as like functions that you write in your program. Okay, so let's again go back to spam from spam. So S is again spam, and then I say s.find PA. What do you think it's gonna return? 1, right? Why do you think it's 1? So it actually just finds the matching string to PA in your original string S, and then it returns the first item. Okay, so can just do this. But let's say you are like, well, s.find, do I have to memorize it? What if I want to use it in a different way? What if I want to learn more about this? And then in that case, you can actually say s.find and question mark. It actually gives you the doc string of this method, which operates on strings. So this says, okay, so see, this actually returns an integer. You can actually tell. And here it says return the lowest index in S where substring sub is found. such that sub is contained with an S start all the way to end. So optional arguments start and end are interpreted as in slice notation. So basically, this is more to give you more idea about the method you are looking for. Okay? But did this operation change anything with the S we had? Did we really change? Actually, can we edit it? We cannot, right? It's immutable anyway. So spam is still a spam. All right? Okay, so there is another method which could be useful for strings again. So you can say s dot replace PA with XYZ. So you are telling the program that, okay, maybe I should put it a little bit up so you guys can see. Okay, so here, we are here. So you are telling the program that replace, wherever you see PA, replace it with XYZ. Okay, so when I do this, is that modifying the string S itself, do you think? No, right? But then what's the output of this? So this is assigning actually to a new variable. It returns you a new variable, SXYZN. So all the PA you had is gone. Now you have XYZ. But what happened to S? Well, again, it's immutable, so it should be unchanged. Okay. See, so S is still spam. Okay. And also there are some other methods specific to strings. For example, you can actually do splits or some case conversions or test the content of a string or strip white space characters of the ends of the string and all that. For example, let's say you have this string that's called line, and you have this A, B, 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 C, 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 D, D, D. And you want to split this string based on the commas. So you tell program that wherever you see a comma, just split the string and then give me a list of these substrings, basically. So what do you think it will return? Yes. So basically, yeah, we are gonna talk about it later, but so it returns you a list. So it already separated all these substrings in your string based on this comma. And then, another method, like for case conversion. So if you have spam or lowercase, you can just say s.upper, and it will give you an uppercase conversion. So in this case, so it made everything uppercase when I typed s.upper. But again, what happened to the what happened to the original S? Didn't change. Okay. I think I emphasized it enough, right? For strings, they are immutable. Should be really clear now. So with strings, you can also do some different tests. You can say, okay, so is my string alphanumeric, or is it a digit? Whatever you can actually think of. For most of these things, I actually don't know them, but from the top of my mind. Although if you use them a lot, of course you'll know it really well. But most of the time I Google, I say, okay, how do I do uppercase? And then I find upper. Oh, okay, this is how it works. If I want to learn more about it, I just look for it and put a question mark and then see what that really means. So in this case, what do you think this is going to return? S dot is alpha. True. Why true? Right. So it's since it's alphabetical, since everything is like an alphabetical item, it returns true. I mean, another nice method you might find helpful is to remove the white space characters on the right side. For example, you can say r.strip. So it actually removes this white space character. So here this, so this actually means put some white space. Basically, it's like next line, add a line to your string. But when you say line.rstrip, it actually removes these two items at the end. And you can also combine two operations. You can actually first remove the white space by running r.strip, and then split based on the comma. So it will first take this line, remove the white space, and then given this one, it actually splits based on the comma, and then it returns you what we actually got before. Okay. So you can also get help by just running this dir of s. So it actually returns a list of all the attributes available to that object. So s is an object. It's a string. It's an object. It actually has some methods that you can apply. So when I look at s, if I say dir s, it actually gives me all these available methods that I can do with s. See, so is alpha, we used it, rstrip and all that. Okay. So for these ones, these are more specific to, these are the things you probably shouldn't touch yet. We'll talk about them later. So when you see this double underscore, that usually means that they are more private methods. But don't worry about it now. So you can look more on these methods that don't have these double underscores. Okay. All right. Like question mark is that to replace question mark. You can also say just help of s dot replace. So it actually gives you what you can do with replace. So here you can read about it. Okay, so this is like you first put the old one with the new one, and then so you can understand what it is really doing. But this is important. So this says return a copy with all occurrences of substring alt replaced by new. Okay. All right. So this is all about strings. Before we move to the lists, anybody has a question? Everybody is following fine? Everything clear? Too easy? No? Yes? Okay, so let's talk about lists a little bit. So the Python list object is probably the most general sequence provided by Python language. So list, as you can tell, it's all about sequences. So they are positionally ordered collections of arbitrarily typed objects. So this is important. So in a list, you can actually, so each item can be of different type. So one item can be an integer, one item can be a string, one item can be another list, So for example, here I can create a list of 3 different type of objects. So what is the first type? Integer. Second type is string. The third one is a float, right? So I can actually create. It already because I'm not returning anything, so it already created L as this. But here I want to point out why I don't like IPython notebook, because here I don't really know what L is. In PyCharm it shows you all the variables when you do debugging. Here, okay, I created, but who knows where it is now, basically. But anyway, so I'm using notebook, so let's not talk too much bad about it. It's for presentation mostly. So now we can, as we did with the strings, we can actually do the same thing with the list. So you can look at the length of a list. So our list is L. So what do you think the length is now? 3. You are not counting on the length of the length of span or others? No? Okay, good. Okay, so the length should be just 3 in this case. And similar to strings, we can actually do the indexing and slicing by the position. So when we just say L0, what should that return? 123, right. Okay, let me put it a little bit up. Right, so it returns you the first item in your list. And again, similar to strings, you can actually slice a list and it returns you a new list. So here, when I said all the way to -1, that means put everything but the last item. So it puts 123 span, but it doesn't put the last one because I'm telling it to stop at the end. Right? Very similar to strings. Okay, there is a typo here. This should be repeat. So you can do concatenation and repetition with with lists as well. So when I say L plus 4, 5, 6, so when I say L plus 4, 5, 6, it's going to create another list which actually has 1, 2, 3 spam and 1.23 and 4, 5, 6. So again, now Python understands that I can actually use plus numbers for different things, strings for different things, and for lists to create a new list. So, so it knows that you are operating on a list. So it understands what plus means. What does this property called that I just mentioned? Yes. Polymorphism, right? Again, polymorphism. So Python, because of the polymorphism property, Python thinks, okay, I know what you mean by plus now. You are operating on lists. So that can only mean concatenating lists. And so if I multiply a list with 2, what does that mean? It's going to repeat. Right? It's going to repeat what you already had before. Okay, so we are now working with lists. Are lists immutable or mutable? Mutable, right? So they are. So you can change them. You can change the values. But here, when we are doing all these operations, we are not assigning anything to the original L. So it's always returning us a new list. So that's why L still stays the same. However, if you want to change it, you can do it. So, but before that, another property about lists is that they don't have any fixed size. Basically, you can keep adding items as much as you want, as much as your memory, of course, allows. So here I can actually add a new item, let's say ni, to the original list L, and then if I return L, what is the length going to be after I do this operation dot append? 4, right? So because we are adding one more, appending one more item. So now the original L has been changed because append changes the list itself, and since list is a mutable object type, we can actually make these kinds of changes. And so specific to lists, like similar to strings, there are methods that you can only use for lists or only make sense for list. For example, let's say, so we just edit a new object, right? We just edit a new item by running append, but we can also remove an item. We can remove an item. So this is item number what? 3, right? So we can remove item number 3 by just running this pop, basically. And then, so it just removed the item, actually this one. And now our list should be back to the original because, sorry, not original. So this is another one. So we just removed 1.23. But since we had this ni that we appended before, it is still there. Okay. So is everybody following fine? Back row? Are you guys? Okay. All right, so since lists are mutable, so most list methods also change the list object in place instead of creating a new one, which makes sense. But you know, so you should be always be careful. You should always think that, okay, so when I run a method, is that really changing anything in place, and do I want that change? So in this case, let's say you have this list called M, okay, and you have these items B, B, A, A, C, C, and then you want to sort them. So what does sorting mean for strings? Yeah, but sorting makes sense for numbers. So, right. So again, Python knows when you say sorting for characters, it actually does it alphabetically sorting. Okay, if it was a number, then it will sort like numerically, right? Okay, but does m.sort do it in ascending order or descending order? Should we just assume whatever and just run it? You know? So this is very dangerous, right? If you don't know how it is doing sorting, and if you need a descending sort, and if it is doing ascending sort, that's not what you wanted, right? So let's first see what it is really doing. Okay, so this does it in ascending, right? This is ascending, right? I always confuse those two. But okay, so this is so the values are kind of increasing alphabetically, you can say. But again, it was important to know what this sort really does. So I want to check it out and see if that actually has any information about either ascending or descending. So I can say m.sort and question mark reverse tables. Okay, so this is in place. Okay, thank you very much for telling that to me. So it actually changed the original list that we had, but it doesn't really say what order, which is funny. So we need to you need to see, you need to play with it a little bit. So after we run this m.sort, so m has changed, right? M, A, B, B, C, C. So what if I say, okay, there was something called reverse, and let's make it true. and then run m again. Oh, okay. All right, so yeah, the doc string maybe was not very helpful, or I didn't maybe understand what it is really doing, but I kind of figured it out, right? So there was this reverse parameter to this function, which was false by default, and when I changed it to true, it made it in a descending order instead of ascending order. Okay. So yeah, so let's just see it one more time for illustration. So see, there was this reverse item which was false. So when you see this, that means actually that's a default value of this function. So when you input it by changing it from false to true, we are basically reversing the operation. Okay. All right. Oh, okay. There is so this list also has this other method called m.reverse. Well, I wonder what that is. Okay, so it actually reverses whatever you have, but it's not like ascending or descending. I hope. I'm just speculating about it. So it's probably better to look what it is really doing, you know. Okay, maybe. Yeah, reverse. Okay, so it's not. So sort is different, reverse is different, right? By name, and it's a built-in function. You can tell. Maybe it will give me more information if I say help. Okay, no, same thing. Yeah, is that a statement or a question? You're making. Oh, okay. Yes. Yeah, exactly. So basically, right. So reverse doesn't do sorting. It just reverses everything. But sorting, by its name, it sorts the values. But if you change the input, that's also called reverse, from the default value, which was false, to true. It actually does it in a different order. Okay. All right. Okay. So nesting is a nice property in Python. We can actually nest Python's core data types like lists, strings, numbers in any combination and as deeply as we like. So of course one immediate application of this feature is to represent matrices or multi-dimensional arrays. So do you guys use matrices in your courses? A lot, right? Especially if you're into data science or machine learning, those kinds of things, or signal processing. There is so much matrices that you have to make operations on, right? So you can basically create a matrix, let's say 3 by 3 matrix, as like a nested list. So all you need to do is so this will be the first row. You are telling Python to have the first row, and then you say comma, and then you tell Python to do the second row, and so on. So each of them, you can imagine them like a different row. And you can also imagine, so each of the entry of this to a different column. Make sense? Yeah, I mean, it looks maybe more clear when I type it like this, but if it was like this, you know, it's a little bit harder to understand. It was actually a matrix. So if you are working with matrices, it's probably better to write it this way. And then, okay, so when I do, see, so another bad thing about IPython notebook. So I forgot to run this amp, and I had another amp, I don't know where, I forgot already, I just keep running, and it gave me this different list that I wasn't expecting for. But I was actually expecting this one, but I just forgot to run this sample. So this is another property that you need to be really careful when you use IPython notebook with the order of the cells you are running, right? So do you guys all agree with me? It's a dangerous thing. Okay, thank you. All right, so let's run this matrix. And now this amp should be a different thing, right? Now we should have our matrix finally, which is going to be, okay, 1, 2, 3, 4, 5, 6, 7. But of course, it's not going to print it as the nice way that you just typed here. It's gonna give this, which might be a little bit harder to interpret, but you know what it is. Okay, so if I get, what is the first item of this amp? What's the first item? Not. Okay, so who says it's 1? The first item is 1. No. I'm talking about. I didn't run this one yet. Okay, maybe I'm giving you too much hints. But that wasn't my question. So I'm asking, what is the first item of amp? Is it 1? Who says 1? Who says 1, 2, 3? Okay, nice. What is the first item of the first item? 1. Good. Okay, good. You guys got it. All right. So if I want to get the second row, then I need to get the second item in the matrix, right? And what is the index for the second item? 1. Right. So now I can just say M1, and nice. I got the second row that I wanted. Okay? Yeah, so you can also get the row 2 and then get item 3 of this row. So this is like the second item of the first item, which is going to be what? Everyone says something different. All right, let's run. Yes, 6. So basically it looks for so 1 means the second item. So go to the second row. And then 2 means third item. Go to the third item in the second row. That gives you 6. And so you guys should familiarize yourselves as much as possible with all these like brackets and all that. Okay. So the way we slice in Python is using these kinds of brackets. And other nice operation about in Python is called comprehensions. So polymorphism, immutability, and comprehensions. So comprehensions are really specific to Python, really nice property of a Python. So in addition to the sequence operations and list methods, so Python includes a more advanced operation known as list comprehension expression, so which is a really powerful way to process structures like our matrices. You can think it may be like a for loop, but it's really one line. So instead of writing for loop in several lines, you can represent some things in Python by just using list comprehension without writing for loop, and it's less coding. And since Python programmers really like less coding as much as possible, they like these comprehensions, but don't exaggerate. You know, if you need to use like 2 for loops, 3 for loops, don't keep adding these this comprehensions. So it will, once things get harder to interpret by just looking at them, then you are probably doing something wrong. Okay? All right, so here, what am I doing? So for row in M, that means go through each row in M or each item in M. So basically, what was M again? So M was this. Go through this item, and then second item, second list, third item. Go through all this. And then once you have those rows, give me the item with index 1. So what do you think it's going to return? 2, 5, 8, right? So I'm going through each of these and get the second item. Look at this row, get the second item. Look at this row, get the second item. And finally, it should give me this column 2, which is 2, 5, 8. So this is important. This is list comprehension. Really some neat property of Python, and this should make sense to you. So is everybody clear with this, what we did here? Okay, nice. Well, did we do anything with the matrix itself, the original matrix? Did we use any functions that might change anything in place? We didn't, right? So the matrix itself should stay the same. All right. Well, let's do a little bit more interesting operations. So let's add 1 to each item in second column. So again, so this was my M. Each of them corresponds to, so this is column 1, column 2, column 3, again column 1, column 2, column 3, but each of them is like whole, this thing is one row, or the other thing is second row, etc. So here I'm saying, look at the second column at each row, look at 2, add 1. Look at the second column in this row, you get 5, add 1. Look at the last row in this matrix. Look at the last row and look at the second column and add 1. Then what should that return to you? This operation. What is the result should be, you think? Maybe I should. Okay, anybody else? Right, 369, right? So to the second column, add 1 to the entire second column. Then, right. And you can also add some if statements. So let's say you want to return the second column of each row only if what? What does this mean? Only if it is 0? Right. So this means you are checking if the item is even. So I'm actually looking at the modulus of 2, and if it is equal to 0, that means it's even, right? So what is that going to return? Four, 5. Okay, so I'm hearing different things here. So again, what are we doing? We are looking at each row and second column. Each row, second column. Here it is 2. Is that even? Yes. So I'll keep 2. I'm looking at the second row, second column, 5. Is that even? No. So I skip that. Look at the last row and second column, 8. Is that even? Yes. So I'll keep that. So what am I keeping at the end? 2 and 8. right? Basically 2 and 8. Okay, and also you can actually just look at the diagonal terms of a matrix. So basically, what should we do to get the diagonal terms? So again, I'm looking at this matrix here. I am actually saying get the first item of the first item. Get the second item of the second item. And get the third item of the third item. That's the diagonal, right? Is everybody clear with this? Is that clear? Yes, right? Okay. So in this case, I'm saying, okay, so give me m, I, and I, which means I can go from 0, 1, 2. So here I actually said for I in 0, 1, 2. So I will be in the first loop, I will be 0, so it will give me m0, 0, which is the first item of the first item. And then in the second loop, I will be 1, so it will return me m1, 1, which is the second item of the second item. And for the last one, the I finally will be 2, which will be the third item of the third item, which is the definition of the diagonal of a matrix. So 159, as you expected, 159. Okay, is there anybody confused with these list comprehensions? No, right? Okay. So you can also, let's say, okay, what do you think the output of this is going to be? Okay, maybe I should hide the hint. Okay, anybody? What is the length going to be? What's the length of this output? Length of doubles, the result, you think? Okay, so let's see. Okay, this looks a little bit more confusing, you think? Huh? Or too easy? Confusing? Okay. So let's see, for C in span, for each for loop in the first iteration, what is the value of C? When I say for C span, the first value of C is S, right? It will give me S first. And now what am I doing with S? Now C's value is S. I'm multiplying S with 2. What does it give me? Yeah, let's call double S. Sounds better than SS. Okay, so that's the first item. Now we are in the second for loop. Okay, so what is the value of C in the second iteration? P, right? And then you multiply P with 2, what do you get? Double P, right? Or PP. And then that will be the second item in your list for your output. And then you keep doing your iteration, and finally the value of C, not finally, in the next iteration, the value will be A, and when you multiply it by 2, it's going to give you AA, right? And same for M. Okay, now can you tell me the length of these doubles, the list doubles? Eight or 4? Who says 8? Okay, there are a few. Who says 4? Who says I don't care? Okay, all right, so I think it should be 4. So let's see. So doubles look like this, right? So yes, you are doubling the each character, but you are doubling it, but assigning it to one item in your list. So this is the first item, this is the second item, and all that. Okay, now are you convinced why it is 4, not 8? Okay. All right. So yes, this is all about list comprehensions for now. So what you should really pay attention is what I am really iterating on. So when I have this 4, so you can think this C as a dummy variable. It keeps changing. So what are the values of your dummy variable when you are iterating over something? And here, since we had spam, we will iterate on this. Okay, so let me ask you this. Do you think, so what do you think the output of this is going to be? Well, is it going to work? Does that make any sense? Let's see. Well, you are operating on a different object. It's not a string. So Python knows when you're operating over strings, when you do for loop, when you iterate strings, yeah, that makes sense. Go through each character. But when you have an integer, what am I going to iterate on? That doesn't make sense. So Python complains about the operation you just ran. That makes sense, right? That's a good thing. Okay, but what if I do this? Do you think it's going to work? And what will the output be? What's the length of the output? 4? 3. Who says 4? Okay, who says 3? Yes, it should be 3, right? All right, so let's run this. Great, yes, it worked, but it actually didn't multiply each of these strings with the value. It just doubled, because now Python thinks that each of these variables is a string. You are giving me a string, 3 as a string, so I'm just going to double it. Okay? All right. So is this clear with everyone? So you see, these kinds of operations really depend on the object type you are working on. Okay, so let's do just one more thing. Again, let's copy this. Okay, what is this going to give me? You think error? Okay, who says error? Okay. Any idea of what it's going to return if it is not going to yield an error? Okay, so great. Yes. Oh, you did it? Oh, that's cheating. Okay, so what am I doing? I'm taking string 3, 4, 5, which takes it as really like a string of like 3, 4, 5 different. So each of them is a character, and then I'm applying another operation on each string. I'm telling take 3, which was a string, but convert it to integer. Now that C, which was 3 as a string, is not a string anymore. It's a value, 3. And then I say multiply by 2. So it's not going to double it now. It is going to, actually, it's going to double it in a different way as a number. It's going to multiply it by 2, right? And then go to 4, which was a string, convert it to integer, and then multiply by 2, and so on. And then when I do this, yes, yes.
3, 4, 5, 8, that will be an error 1.
Exactly, yes. Let's see that. Let's keep pushing the limits. Let's say here I add a. So, right? Yes, that was an error. Why was it an error?
Say 1, 2, 3, but the SQL string.
Right, right. Exactly. But what do you think about this? Oh, I just can't stop now. What if I have string here? Is this going to work? Actually, do I need to say string here? I don't, right? Because everything is a string anyway. Just doubled everything. Okay, what if okay, I'm also not sure this is going to work. Oh no, let's say type C is no, I want to say if it is only numeric. Okay, so let's see. So I want to say, let's say if C is 4, C dot, why doesn't it autocomplete, is, okay, it doesn't autocomplete, is digit, thank you. Okay, maybe I can use this, right? So what if, yeah, maybe I shouldn't type, I should use type. Okay. Okay, what am I doing? Go through all this. If C is digit, then do this operation. Do you think it's going to work? What did I do here? So I added a condition. So I'm adding a condition. I'm telling, go through each character in this string, and then if it is a digit, then apply this operation. So should be fine, right? What do you think? Anybody has a complaint? Anybody thinks it shouldn't work? Everybody's clear with what I'm doing here? Okay, nobody's confused, right? Nobody? Okay. All right, so let's see. Oh, it worked.
So that applies to condition for every iteration.
Right, exactly. So for each iteration, it looks if this is a digit. If that's a digit, return it to me. I'm saying. Okay.
What if have class string A? How should know when do it in like a class A? Maybe they should just times two times first time to then class A or first class A then represent it in same time.
What do you mean first plus a?
It's a string about then 345.
Right.
Then you plus string A.
Yeah.
Becomes
3, 4, 5, 8.
Yeah.
Yes.
I mean, how to just to finish the front part. Then plus A.
Finish it from, oh, you mean add it to the front? Is it what you are saying?
3, 4, 5 will double first and plus A.
Oh, okay, let's try. I have nothing to lose to do that. Okay, so is this what you meant? What happens if you do this?
This is the pattern. How you know you pass first, then double the string.
Oh, because it looks at the order. Yeah, so another way to demonstrate how it's actually doing it. I mean, I know we didn't really do for loops yet, but one way to do that is actually oh no. So I can actually do this. Remove the condition. Oh, what is this? Okay, C. So, oh, sorry, I forgot to add A. So this is the order it goes through. So it's actually here. This is a really simple operation. I'm just telling, show me the C. Whatever C you are iterating, just give it to me. So that gives you 3, 4, 5, A in this order. But I don't know if this will work. What if I do this? I don't know really, but let's see. Oh, string object has no attributes. Oh, because it's a yeah. Because okay, so what is the problem here? Why didn't it work? Exactly. So I had this. So I'm actually working on a string, and string doesn't have this operator. But what's that? If you send it as a list, it should work. Yes. For example, so if this was okay, maybe you guys will find these useful, right? So I shouldn't change the output of the cells probably. So if I make it like 3, 4, 5 and A, and then reverse and then iterate. Oh, non-type. Why did it complain? Okay, let's see my list. Non-type object is not iterable for C. So it was reversed, right? So okay, let's see my list has reverse. Oh, okay, I know what is going on. Huh? Okay, so what are you suggesting?
I'm just saying that you have to use the variable name.
Variable name?
Yeah, just like the my list. And before, like,
Yes. Right. So basically, this this function doesn't return me anything. There is no output. So, for example, when you run mylist.reverse, doesn't return anything. But what it is doing is, it's actually, it just reversed the order. So it did it in place. It didn't give me an output. That's why if you really want to do this, so you should, what you should do is you say mylist.reverse, and then it already did it in place. So now you can run it. Is that clear? Nice. Okay, so there is another thing, another property about Python is you can just use this function range, which is a built-in function. So basically, when I say range 4, it what do you think it should give? Okay, so it doesn't return a list, but it's an iterable. Don't worry about it yet. Now it's a different type. But this is actually to illustrate how to use range. So that actually generates. So it's a generator basically. So that generates a successive integer, 0, 1, 2, 3. Do you think 4 is included? Do you think 4 is included or not? You know, usually, for example, when we do slicing, we do, if you go up to 3, that doesn't include that item with index 3, right? So Python has this property. So when you say range 4, it gives you 0, 1, 2, 3, but not 4. It stops at 4. So range 4 doesn't include 4. So here, exactly like generate values from 0 to 3. But I'm converting it to a list so I can see the result more like in a meaningful way. So I say list that actually generates the numbers I want. So again, remember, we are lazy. We don't want to type 0, 1, 2, 3. We rather type range 4. That gives us 0, 1, 3. Oh, is there a question with you guys? Any confusion? No? Okay. You can, of course, you know, you don't have to range always from 0 to whatever number you want. You can generate values that start from -6 and at 7 with increments of 2. So you know, you can give this parameter input to. So basically it gives -6, -4, -2, 0, 2, 4, 6. Okay? All right. So again, another list comprehension example. So what do you think about this? So if I run this, I say for x in range 4, but please don't tell me after you run it in your machine, okay? Tell the result only if you can tell it without compiling anything, without running anything. Okay, what is the first item?
0.
Okay, first item is 0 or 0, 0?
0.
Who says just 0, first item? Why do you think it's just 0? Huh? Okay, but why can't that be 0, 0? Right. Okay. So what is this operation? Double star. Power, right? So in your range, in the first iteration, x is 0. 0 power 2, 0. 0 power 3 is 0. So the first item is a list of 0, 0. So it's 0, 0, not 0. Then the second item is 1, 1, 1. Third item is 2, 4, 8. Last item is 3. Exactly. Yes, you guys got it. Okay. So see, this is a list of lists, basically, because for each entry, I'm returning a list, basically. Okay, you can go fancier. We can add a condition. Okay, so for this one, what do you think the first item should be? What is the first item of this output? Okay, so let's go through this. So range -6 all the way to 7 with increments of 2. What is the first item in your iteration? First x is -6, right? Is that greater than 0?
No.
Pass. What is the next item? -4. Is that greater than 0? Pass. What's the next item? 0, right? Oh, sorry, -2. Okay, sorry, I was impatient. And then your next item is 0, let's say. 0, is that greater than 0? No. Pass. Next item, 2, is that greater than 0? Yes. And then what am I gonna return for 2? Exactly, 2, 1, 4. And then what is the next item? After 2, 4. And then you return, is that greater than 0, of course? And then you return what? 4 to 8. Okay, so that's it. It's clear, right, guys? So you should always, when you do list comprehension, you should always pay attention to what you are iterating through, and what is the condition, and what is the output for each iteration. Okay, so that was all about lists and strings. We didn't talk much about numbers, but they were, I think, very preliminary anyway. So let's move to other object type, the core Python object type, the dictionary. Okay, so Python dictionaries are not sequences, but they are more mappings. So they are not like lists where you can actually access the value by just indexing or slicing. So you are mapping values from a key to a value, okay? So they simply map keys to associated values. So dictionary is the only mapping type in Python's core objects. So these are actually also mutable. Like what? Like lists. So they can be, of course, changed in place, can grow, shrink, whatever, so that you can actually just pretend that they are, you can always keep in mind that they are changeable or mutable. Okay, so let's see how we can create a dictionary. Let's say this is my dictionary, D. My food is spam. Maybe not a very good mapping, but that's what it is. The quantity is 4, okay? So I'm mapping quantity 4, and the color is pink. So if you want to fetch the value of key food, so what are the keys in this dictionary? Can you be louder? Right. So if I look at the value of key food, what is the output going to be? Right. Oh, what happened? I forgot to run this one. That's it. Okay. All right. Now I got my spam is food. You can actually change the values in place. As I said, they are mutable. You can change them. So change the quantity, which was 4. So what am I doing here? Plus equal 1. This is actually just again lazy way of doing this operation. And this is not only in Python. This is common in many languages. So basically, instead of writing this, since we are again lazy people, we just say plus equal 1. So that understands what it is doing. So what if I run this, by the way? What do you think the output of the quantity going to be now? 5? Who says 5? 6, right? Because I'm doing the same operation twice. I'm adding 1 twice. Just in a different way. Oh, okay, quantity 6. So yeah, we defined the dictionary this way, but there are other ways to define it too. You can actually start with an empty dictionary with these curly brackets, and then you can keep assigning the value you want. So here, for this dictionary, I say the name. For name, map it to Bob. For job, map it to Dev. For age, map it to 40. And then I can do this. And name is, of course, what? If I want to fetch the value of name, what is this? What's the output? Bob, right? Just checking if you guys are paying attention. Okay, what did I write here? In other applications, dictionaries can also be used to replace searching operations. Indexing a dictionary by key is often the fastest way to code a search in Python. So this is, so if you, let's say, you want to get the values really fast and you know the mapping, so this is really a great way to, great opportunity to use dictionaries, because they are really, so if you have taken data structures course, you should have been told that accessing the information in dictionary is really a fast way to do it. So that's why you use it to create like lookup tables, really fast fetching. Okay, so we can also make dictionaries by passing the dictionary type name, either keyword arguments or the result of zipping together. So here, for example, this is another way of creating a dictionary. I say name maps to Bob, job maps to Dev, age maps to 40. But here, keep in mind that when I did it other way, I gave this name as a string. So for example, here I said name is a string. Or when I first defined it, I said, okay, there's no name here, but food is a string, okay? So the keys, I defined it as that, but if this is the way you want to use, like with this dict operator, then you don't need to type like this. You actually just say name. It understands that it's a key. All right, so here I just get the same kind of dictionary by just doing this. All right, you can also do zipping. So Python has this other nice property, which is called zipping. So when you say zip name job age and Bob dev 40, that actually maps name to Bob, job to dev, age to 40. So this is really a nice thing that Python provides. So for example, if you want to understand zipping even more, by just using the list comprehension we learned, you can actually say, let's say, A, B, okay, for A, B, okay, I hope this will work, by the way. I'm first time trying this. Let's say, let's just copy. Don't forget to close it. Okay, so do you understand what I'm trying to do here? So what did that do? So basically, when I zip these two lists, at each iteration, it takes the first values from both name and Bob, second values job and dev, and third values age and 40, basically. That's what zipping is really doing. If you have these two lists that you want to iterate through, okay? All right, so nesting. So as lists, we can also create dictionaries that have dictionary as another value, which is mapped by another key. So for example, I can create this dictionary where the value for name is another dictionary. And value for jobs is what? What's the value of jobs? Guys? What's the value of jobs of this dictionary? It's a list, right? Okay. And the value of age is what? Integer? Float, right. Okay, so let's run this. Oh, I got an error again because I forgot to run this. So for this name, when I try to access the value of name, it's going to give me this dictionary that I just defined. And yeah, so what does this give me? Name and last. What do you think it will work? First of all, do you think rec name and last will work? It will work. Anybody who thinks it doesn't work? You seem skeptical. Okay, so what is the output? Smith, right? Perfect. What about jobs? Rec jobs. Right. So it will give me a list, right? So what is the output of this? Rec jobs -1. Manager. Huh? Yeah, that's the last one. Yeah. So for jobs, so it was a list which was dev and manager, let's say. You can actually append a value to this. So rec jobs dot append janitor. Now, what is the jobs going to be for this dictionary? What's the length of these jobs going to be? The length? 3, right? Because I just appended another job to jobs. So, see? So basically you can see that we can change the values of dictionary, basically. Okay. Okay, so yes, the real reason for showing you this example is to demonstrate the flexibility of Python's core data types. So nesting allows us to build up more complex information structures really easily. Yeah, so building a similar structure in a low-level language like C would be really tedious and require so much work, because here I am just operating with too many different data types and things still work together. All right, so we said polymorphism, immutability, and garbage collection is another property that you should know. So again, in lower level languages like C, we should be really careful to clean up all the object space when we don't need them anymore. But in Python, when we lose the last reference to the object, in other words, when we assign its variable to something else, then all of the memory space occupied by the previous object will automatically cleaned up. So basically, we had this complex variable, rec, in our memory somewhere. And then when I say rec equals 0, it actually did all the cleaning for me. It cleaned the space that I was using before, and it just assigned 0. Okay? So fetching a non-existing key is a mistake, as it should be, right? So let's say I have this dictionary, A maps 1, B maps 2, C maps 3. I run it, 1, 2, 3. And then let's say I can actually, after you define a dictionary, you can assign new keys. You keep assigning. So here I'm assigning another key, which is E, and its value maps to 99. And now when I look at D, now my D became A, B, C, E with the keys and their values. But what if I do D, F? Give me F. Is it going to work? Should that work? It shouldn't work. Because there isn't no key which is F, so it should give me an error, which is a good thing. You can actually check if a key is in the dictionary by just saying F in D. So this should return what? F in D. False, right? So it's either true or false. False. So E in D. So let's see. We have E as a key here. So what should that return? Yeah, it's true. Okay, but also, I mean, you can also avoid accessing non-existing keys by using this get method. Basically, you just assign a default value. So if this dictionary D doesn't have any key that has X, just assign 0 to it. So D.get X or 0. So what's the value going to be in this case? We don't have X in our dictionary, remember. There is no X. So when you run this D.get, it's going to try to fetch the value of X, and it's not going to find it. Then it's going to give you the default value 0. Basically, you can, okay, let's see, D.get, let's say help. See, so the default value is none by default, but you can change it. So that means if I just say that get X, it returns nothing because the default was none. Okay? But when you type 0 here, it returns because its default is 0 now. All right, so you can grab a list of keys with the dictionary .keys method. So basically, all you say is d.keys, and then when you say keys, when you assign it to a value by converting it to a list, it gives you the list of keys, but here it's important that these are unordered. So dictionaries are unordered. So it can give just a random order of your keys. So A, B, C, E. Okay, it's that looks pretty ordered, but it was really by chance, basically. So if you want to sort it, okay, I want to change something here. Okay, so what do you think this should be? Is it doing it in place? So it's going to do it in place, right? So I have this key S variable that I already defined. And when I run a sort to this, it's going to do the reversion or reverse sorting in reverse order in place. ECBA. Okay? Or you can just iterate through sorted arrays like this. You know, so I'm really not doing anything here. I'm just saying for each key in keys, just print me key with this arrow and give me the key. So I'm just printing. This is just to warm you up a little bit with the for. But can I actually do this with, again, list comprehension? So what should I do? Can I do this? Key, D key, for key in key S. Do you think this will work? No? Why shouldn't that work? What's the problem? It worked. So it actually, so it gave you a list of lists where the first item at each sublist is the key, and the second item is its value. Okay? Okay, so we could do dot sort, or you can also, there's also this built-in function sorted. So this already applies the sorting to the dictionary itself. Just in case you know that there is also another built-in function called sorted. Yeah. Okay, so I think this is a good place to stop. I don't want to start the tuples today. We can continue in the next class. So anybody has a question so far? No? Yeah, I'm gonna put this to the GitHub. Yeah. Okay, so I'll probably submit the assignment by Monday, but you guys will have more time for the first assignment, probably 2 weeks, to make sure that you have everything set up right, you know, if you have any issues. Okay? Thank you so much, everyone.